Now the next thing that we need to do is calculate my in-use column. We can take almost the same one-to-one logic that we used with pandas. I'm selecting my state column, and then I'm performing a very similar .map. Polars just calls this .map underscore dict because we're mapping specifically a dictionary. Pandas will do a little bit of introspection. They're actually working to disambiguate their .map. Right now in pandas, you can .map a function, you can .map a series, you can .map a dictionary, and it gets confusing which one of these is actually going to be fast and which one's going to be slow. The .map for a dictionary is going to be quite fast here. Another workaround that I would personally do in either pandas or polars is cast this column to a categorical type, and then that way I don't actually have to use actual string values. And we actually do have a categorical type here, so these checks should actually be quite fast, and these are both categoricals right in pandas and polars. And the way that we can check that, I can even prove that to you. I'll go ahead and just print out the df.schema. Now, polars has this idea of a schema, right? These are going to be enforcements of a column to a specific data type. I always need to abide by these schemas. If I try to change them, polars will likely complain. Whereas pandas, if you change the schema, if you change a data type from, say, a float to an object type, pandas will just silently do that. Say you add the value none instead of nan into one of your columns in pandas, pandas will just let you do that. It won't complain. Polars is a little bit better at making robust pipelines. That is not to say that you can still make bad pipelines with polars, because you absolutely can. You can have errors in your logic that are not caught by the code, but a little bit more stricter enforcement on the data types is going to help you snuff out just a couple of errors here and there. And so with our schema in use, I'll assign these two new columns. You can see we're taking the exact same thought process that we applied in my pandas analysis. And now all that's left to do is to perform my aggregation looking at every single month, or the end of every single month. And remember, we're going to do that by device. Now, pandas has the group by with the grouper syntax that we used. You can also, if you set your index up correctly, if I were to reset the device out of my index here in the pandas analysis, I could do a dot group by dot resample, which will give me very similar, or the exact same results actually. But here you can see I'm using a grouper object within group by. Polars instead, if you want to perform a dynamic group by, right, in this case we are computing a window with dynamically sized edges, because polars has to figure out how many rows are going to fall into this 1 month period, and pandas has to do the same thing. They simply, instead of integrating this into the built-in group by, they added a separate group by method specifically for working with time series or windowed time series. So I'm going to use group by dynamic. I'm going to say that my time series column that I want the dynamic binning to be done on is my time column. I want to group every 1 month together. Now, polars does have a very slightly separate syntax for these relative rules, for these recurrence rules, I should say. And so for these recurrence rules, we're going to be using 1 month, which is 1 MO. I think it's a little bit better than pandas in my opinion, because you have to remember, wait, is capital M month or is lowercase m month? Which one's minute, which one's month? That ambiguous, or that gets de-ambiguized by polars here. And then we pass in our by parameter. Now, we want to perform this dynamic group by on every single device, or within every single device. So we're going to be looking at 1 month within every single device based on my device and my time columns. Now, all that's left to do is I need to aggregate each of my deployed states and my in-use state, right? Before, with pandas, you saw me do this with a .groupBy.last. But now in Polar, since we work with expressions, we're working with individual columns, I can simply just say, well, I just want the last based on each of these columns. And that way Polars can do any query optimization or anything like that that it needs. There's not going to be much optimization that can go on here, since we are just working with the last value of 2 separate and distinct columns. The very last thing that I can do is I'll calculate my signal column just as I did before, and this will give me the ability to analyze my data just how I did in pandas. Now, let's go ahead and wrap up this analysis. I'm going to group by my time, which is going to be my monthly bins. I'm going to get the sum of my signal, and we see a nice reconstitution of the same exact results that I got from pandas that I did in Polars. So for the month of January, there's no devices that meet this criteria. And then finally in the month of March, we see our first 2 that meet this criteria. Now, with all of that being said, we've talked a fair amount about Polars mechanics. Let's check out another small analysis that we can do in both of these, or with both of these tools, to understand the difference between them. What is the average amount of time that a device was under maintenance? So for this analysis, very quickly, I'm going to set up my index slightly differently. I'm going to move the state into its very own column, and then I'm going to use just a little index trick here. I actually do want to use time both as a value and as part of my index here to perform slicing. And so I will actually make a copy of my time column, and I'm going to tuck it into my index. That way I can maintain my time column as well as my index. The trick to this analysis is going to be some type of self-join with a lagged version or a shifted version. So here you can see I'm just taking my original data frame, I'm grouping on the device, and then I'm shifting those, and then I'm going to add a suffix called lag to indicate that these are the lagged versions. And so every row that you see in here is simply the previous row of this portion of the data frame. These are nans on the right-hand side because I don't have data values. And here you can see on my next row, I have my provisioned my March 22nd, and that's exactly the state that it was in before. So now I'm very able to calculate the duration that we spent from one state transitioning into another state. And that's a simple dot assign. All I do is I take my time column and I subtract my time lag column. Then I check when were we in maintenance, and I'm going to check that on my state lag. You can see I'm using the .query instead of .lock. There's a lot of different ways to filter your pandas data frames. If I wanted to rewrite this with .lock, of course, we would use a lambda here. State lag just like that, and then asking it when it's equal to maintenance. Now, I think the .query syntax is just a touch more readable, and especially since I'm performing a simple filtering operation like this, I will actually end up reaching for the .query. But I'm not too concerned about performance. That's not the reason I'm using .query here. Okay, so now that we have the duration, the amount of time that we spent in any given state, I can simply perform a group by on my device, and then capture that duration column and take the mean. And this will give me, on average, how long was any given device in maintenance for. But how do we do this in Polars? Well, of course, there's no setting of the index. Polars doesn't have an index. Instead, we'll need to assume or tell Polars that our columns are sorted. And so I'm going to assume my columns are sorted because I am familiar with these data. Now, Polars might not know that. And so we can tap into some of Polars columns to actually check if the Polars understands that this column is sorted so that I can use these fast track operations. Now, that's part of the flags API. So if you check out a given column from a Polars data frame, you can check its flags to see if Polars knows whether or not this column is sorted. And you can actually set that manually, and that way you don't have to pay the cost of calling an actual sort. So we could check the flags on a given column. And if we know that column is sorted, but Polars doesn't know it yet, well, we can just tell Polars that this column is sorted to use any fast track algorithm. So what we need to do here is, instead of our group by operation that we performed in pandas, or I should say, instead of our self-join, or very explicit self-join, we're going to use just kind of an assign approach. We're going to use a with columns approach in order to perform our self-join. And what I'm using here is a selector from Polars. Polars has a lot of different ways of selecting one or more columns to work with. And here you can see I'm actually importing this. This is from polars.selectors. There's a lot of different things that you can do. You'll see a couple of others like cs.match for performing like a regular expression like selection of columns. But I'm just going to say, given all my columns, shift all of the rows for those columns down by 1. I want to do this over each device, right? This is kind of our group by transform logic. And then because I'm going to be assigning this back as a new set of columns against my original data frame, I want to add a suffix to every single column in this data frame. So you get some pretty powerful syntax here to work with Polars, which I do enjoy. Then from there, we can calculate our duration column, which is simply our time column minus our time lag column. We filter down to the just the maintenance states, and then we perform our group by ag, just getting the average duration here. You can see we get the exact same output. So the polar syntax actually does translate, or some pandas syntax does translate fairly nicely, like you can see here with .assign and .with columns. Now there is a caveat here that we'll get into later, so don't just go ahead and replace .assign with columns if you're transitioning from pandas to polars. There will be a caveat here that I'll bring up, but I do enjoy the syntax, right? You have your .select for selecting specific columns. You have your with columns if you just want to keep your original table and add extra columns to it. You have .filter if you want to reduce the number of rows that you're looking at, and of course you have your group by for your group by logic. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.